Today I'll talk about mathematical basis of decision tree. It is part of my series of lectures on machine learning. This is a structure of decision tree I have taken from this internet source. There are various nodes, and at the end there are leaf nodes. The very first node is known as root node, and part of tree is also known as subtree. We can make decision tree using one of the various algorithms, and these include CART, which uses Gini impurity. Then we have ID3 algorithm, which uses information gain and entropy. Then we have C4.5 algorithm, which uses gain ratio. There were some shortcomings of ID3 algorithm. So we have C4.5 instead of ID3. Then we can also make use of chi-square test to make decision tree. And finally, we have variance reduction method to make decision tree. So let us see one by one each of these algorithms. First, we take CART. So CART stands for classification and regression tree. It uses Gini impurity. So Gini impurity of a leaf node is defined as 1 minus probability of yes square minus probability of no square. And total Gini impurity of an attribute is equal to number of items in a particular leaf divided by total items multiplied by Gini impurity of a particular leaf node. And this is summed over all the leaf nodes of a particular attribute. So attribute with lowest total Gini impurity is selected. So let us take an example. If there are a total of these 30 students and we want to decide whether they play outdoor or not. So one of the attribute is gender. So if we divide the students on the basis of gender as male and females, so out of these total males, 9 play outdoor games and 3 do not play outdoor games. Out of these total 18 female students, 5 play outdoor games and 13 do not play outdoor games. So the Gini impurity of our entire set of 30 students is 0.5. Gini impurity of our set of males is 0.42. Gini impurity of our set of females is 0.40. So the total Gini impurity is total males divided by total students multiplied by 0.42 plus 18 females divided by total students multiplied by 0.40. I am sorry, this is 0.40. So the total Gini impurity is 0.408. And we select the attribute with lowest total Gini impurity for our split. Then we go to ID3 and C4.5 algorithm. There is slight difference in them. As we have seen that C4.5 uses gain ratio. So what is entropy? So entropy measures the impurity of a collection of examples. Let us say if the collection set is X. Let P is a proportion of positive examples and Q is equal to 1 minus P. That is proportion of negative examples or no. So entropy of the set is equal to minus P log P minus Q log Q. And this logarithm is on the base of 2 because we have binary classification here. So entropy varies from 0 to 1. So this is entropy. It varies from 0 to 1. And entropy of 1 means most impure collection. So entropy of 1 means this is most impure collection. And this happens when the probability is 0.5, because if probability are at the extreme, then our set is almost pure. And if probability is 50%, our set is most impure and with an entropy of 1. And the pure set have entropy of 0. Information gain measures the reduction in entropy caused by a partition of the collection set according to the particular attribute A. So this is the formula for information gain. So this is the information gain. The formula which have been, this formula have been expanded for the attribute with two possibilities, A and B. So let us see with our same example. We have a set of 30 students and we split them on the basis of gender. And these were male students, 12 male students, 9 play outdoor. And these are 18 female students, out of which 5 play outdoor games. And these are the probabilities, and these are logarithm of the base 2. These are probabilities, logarithm of the base 2. And the entropy of our entire set is 0.99. Entropy of males is 0.88, and entropy of females is 0.85. So the entropy of entire set minus the weighted average of entropy of the leaf nodes is the information gain, and the information gain in this case is 0.128. So similarly, we select an attribute in which we have the maximum information gain. Then split on the basis of chi-square test. Here chi-square is calculated using observed frequencies of a particular leaf node, but by using expected frequencies from parent node. So expected frequencies are taken from the parent node. This is unlike the conventional chi-square test, and the difference is also there in the formula. This is the formula for chi-square, which is used in decision tree making in machine learning algorithm. Here we are doing square root. In conventional chi-square test, we do not use square root. So this is the same example. We have a set of 30 students. We divide them on the basis of male and female. So this is the contingency table for chi-square. These are the observed frequencies. Out of the 12 males, 9 plus 3, 9 play outdoor games. Out of these 18 females, 13 plus 5, 5 play outdoor games. And from where do we get expected frequencies? We get expected frequencies from the entire set. So this was the entire set, and 14 play outdoor game out of 16 in out of 30. So the expected frequency is 14 by 30 for outdoor, and who do not play outdoor is 16 by 30. So these are expected frequencies, and from these two number of observations, we calculate the chi-square. Then we select the attribute with maximum chi-square value. Then finally, reduction in variance. So reduction in variance is used for problem with a continuous numerical outcome variable. So in our previous examples, we have outcome variable which was categorical. But if we have outcome variable which is numerical and continuous, then we need to use reduction in variance method to make a decision tree. So little bit more about decision tree. So decision tree, what are the features of decision tree? They are non-linear. So I'm sorry, this is non-linear in nature. They are more time consuming, but they are simple to interpret, but they are also prone to overfitting. So if we keep on making decision tree till at the leaf node, we have single sample, then we are prone to overfitting. So how do we avoid the problem of overfitting, or how do we reduce the variance of decision tree algorithm? This variance is for bias variance trade-off. So we can do either pruning of tree, we make tree with limited depth, and we can also use ensemble techniques like bagging, for example, random forest. So this is all for today. Thank you very much.